He is the chair of the scientific committee for the conference scientific committee, and I would like to express my gratitude to Richard for the amazing work he's done to set up this event in such a meticulous and thorough way. And I have no doubt that this will be by far our best conference today. So thank you very much for joining us again. Please enjoy the event, and I would like to hand it over to Andy. Before I go, actually, I need to remind you of a few housekeeping tips that Sarah asked me to share with you. Please make sure that you stay muted throughout the conference. If you have any issues with technical problems, please contact specifically Samantha Royland. Every chair will explain how the Q&A will run, so perhaps I don't need to elaborate on that, but we will use the Q&A function of Zoom. And remember that the meeting will be recorded, so if you don't want to appear on the video, simply turn off your video function. And I would also like to remind you that we have a hashtag ProPASS Conference 2020. Please take screenshot, post anything you think is exciting or interesting about the event. Thank you. Andy, over to you.
Thank you, Manos. Hello, everybody. Welcome. My name is Andy Atkin. I'm an associate professor at the University of East Anglia, and I lead the harmonisation work stream in ProPASS. The theme for our first session today is novel insights on physical behaviour and cardiometabolic health from the ProPASS Consortium. And we have 4 speakers lined up for you in this session. There will be a little bit of time for questions in between presentations. So as Manos said, please use the Q&A function, which you will see at the bottom of the screen in Zoom. Please use that to submit your questions. Our first speaker is Dr. Richard Pulsford from the University of East Anglia, from the University of Exeter. He's a senior lecturer in physical activity and public health. And the title of his presentation, as you can see on screen, is The Impact of Selected Methodological Factors on Data Collection Outcomes in Observational Studies of Device-Measured Physical Behaviour. Richard, over to you.
Thanks, Andy. Can I just check that you can see my slides okay? Great, thank you. Thanks, Andy, for the introduction. My presentation today is going to be on findings from one of the early pieces of work undertaken by the ProPASS group, a systematic review examining whether the methods we use to measure physical behaviour in cohort studies actually impact the data that we're able to obtain. So observational studies have and will continue to make a substantial contribution to our understanding of human behaviour and health. The inclusion of accelerometer-based measures of physical behaviour now offer unprecedented insights into the impact of patterns of physical activity, sedentary behaviour and sleep on health across the life course. But a number of key challenges still remain. These include, firstly, the need to obtain valid and, I guess, as complete data as possible for as much of a given observation period as possible, and then to be able to do this in the desired sample of people, such that, for example, inferences can be made to the populations that we want to understand. Now, ProPASS, as Manos mentioned, is expanding, and in doing so is supporting existing and new studies to integrate device-based measures of physical behaviour into their work. So in order to facilitate this, we set out to understand better, firstly, what methods have been used across the field, and secondly, how decisions we make around these methods might impact data collection outcomes. In particular, we were interested in key decisions around device choice and device placement, so where on the body accelerometers are worn, the distribution method of devices, so whether they're set out by the post or whether they're actually given to people in person, whether participants have followed up during measurement periods by investigators, and what we ask of participants in terms of daily or weekly accelerometer wear. Now, these decisions might be made for a wide variety of reasons, but we speculated that these decisions could influence the extent to which measurement protocols are more or less easy or acceptable for participants, and may therefore influence things like recruitment, attrition or loss of follow-up, adherence to accelerometer wear instructions, and even device or data loss. And the potential consequences of these things are serious. It can limit our insight into behaviours and their relationship with health. We can end up with biased experimental samples where there's a systematic difference between those who can and do and those who can't and don't provide the data that we need for our analyses. We have threats to internal validity and, of course, our limited ability to make inferences about the populations that we're interested in. So with this in mind, we set out to examine whether the methods that we use and the extent to which the measurement methods that we use to collect data on physical behavior using accelerometers might influence the physical behavior data that's returned in these studies. So to do this, we undertook a systematic review and meta-analysis of methods employed in studies of physical behaviors in adults. We followed the PRISMA framework using a 4-step process. So using literature searches to identify papers, and then from these papers, identifying unique observational studies. For each one of these studies, we extracted data regarding the methods used for assessing physical behaviors, and then tried to make sense of these methods using a combination of meta-analysis where the data permitted and narrative synthesis. Now, I'm not going to go into huge detail this morning on the methods that we used in this piece of work, but the study's been published in IJBNPA, so I will refer you to that article to get a better overview of the 4 methods employed. And I'll share a QR code at the end of this presentation so you can quickly look at that article should you want to. A quick mention of our inclusion and exclusion criteria. So for this review, we were interested in studies that used accelerometer-based measures of physical behaviors. That were observational studies by design, so either prospective or cross-sectional studies, and that included adult participants only. So we excluded studies of pediatric populations and either clinical studies or studies of clinical populations. For each study, we then identified how many separate physical activity measurement waves have been undertaken. So important to remember that the unit of assessment for this review was a physical activity measurement wave. So for example, the 1970 British birth cohort, although there's been multiple waves of measurement over time, there's only one measurement wave that included device-based measures of physical behavior. Whereas with some studies, there have been multiple measures of physical behavior. So these could be repeated cross-sectional studies like Haynes, or prospective studies with repeated measures in the same population. So for each measurement wave, we extracted the following information. We started with some fundamental information about the study itself. So the study name, location, study design, when the study took place, and the number of people invited. We extracted data on the physical behavior measures themselves. So the accelerometer used, where it was worn on the body, how it was distributed to participants and then returned to investigators, what was asked of participants in terms of accelerometer wear instructions, and whether or not participants were followed up during the measurement process. And our primary outcomes for this piece of work were the number of people who consented to wear a device, the number of devices lost during measurement, the number of people who adhered to wear instructions, and the average daily accelerometer wear time. So we identified 95 observational studies, and that's comprised 123 individual study waves of accelerometer measurement that met our inclusion criteria. And we initially used random effects meta-analyses to examine, firstly, the proportion of invited participants who consented to wear a device. So that's the first column on the table, percent consented. The proportion of devices lost during measurement, percentage lost, and the proportion of participants who consented who then adhered to wear instructions. So that final column, percent adhered. Now, across studies, the average proportion of invited participants who consented was around 75%. The average proportion of data lost was around 1%, and the average proportion of participants who consented who then adhered to wear instructions was around 89%. But in all cases, the between-study variance was very large. So we were interested then in the extent to which a number of methodological factors might explain this variance. The methodological factors we were interested in were the study design, the device and wear location, the distribution and return method, again, whether participants were followed up, and also the age of the study, so when the measurement took place. So we used multivariable meta-regression models to examine these factors as potential effect modifiers. And collectively, these factors explained around 23% of the variance, 27% of the variance in the proportion of people who consented to wear a device, around 70% of the variance in data loss, and around 12% of the variance in the proportion of people who adhered to wear instructions. And the first important factor I wanted to discuss in more detail is device wear location. So this figure shows the proportional differences in percent consented, percent loss, and the proportion of people who adhered to wear instructions according to device wear location. In each of these analyses, the reference category was study waves which employed devices worn at the waist, and the data points represent the weighted mean and 95% confidence interval for the different wear locations shown on the x-axis. So you can see from the middle panel that compared with study waves with devices worn at the waist, the data loss was 4% and 5% higher when devices were worn at the thigh and when multiple devices were employed. And compared to devices worn at the waist, adherence to wear instructions was higher in all device placements, but this was significantly higher when devices were worn at the wrist, where the difference was around 14%. We then looked at the accelerometer distribution method in the same way using multivariable meta-regression. In this analysis, the reference category was in-person distribution of devices, and the comparison group is where devices were distributed via the post. So the proportion of people who consented to wear a device was on average 30% lower when devices were sent out in the post. And the proportion of people who adhered to wear instructions was around 15% lower where devices were sent out in the post. Lastly, I wanted to comment on wear instructions and wear time, and we examined this part of the data using narrative synthesis. And the first thing to conclude was that wear instructions across studies are very, very variable. But actually, there was a tendency for wear time to be higher in studies where devices were worn on the wrist. Now, in this study, each data point represents an individual study wave, and they're color-coded according to the device placement, where on the body the device was worn. And they're separated here into quartiles according to sample size. So the smaller studies on the left-hand side and the larger studies on the right-hand side. And you can see the data points at the top of the figure there, and largely the orange and yellow data points where devices were worn at the wrist or the thigh, indicating higher wear time overall on average across the measurement period. So what can we learn from these findings that can help ProPASS as a consortium to support new measurements of physical behaviours in new studies? So we made 3 key recommendations. The first was around comprehensive and standardised reporting of methods, which can facilitate the sharing of best practice, comparison between studies, but importantly, the harmonisation of data by consortia. Now, while reporting of methods in studies included in this review was often very comprehensive, there were significant gaps in the information we were able to obtain. So we have designed and released a reporting checklist, which is a supplementary file in our IJBNP article to support colleagues with this. The second key recommendation was around optimizing data collection. So decisions around device wear location, we understand are very, very complex and multifaceted and may reflect differences in the study design, the study setting, and the population, and also the study objectives. But in this review, it's worth noting that rates of consent and adherence to wear instructions were higher in studies where devices were worn at the wrist and comparably high in studies where devices were worn at the thigh. So this may reflect differences in acceptability, which have been noted in previous studies. And I will encourage you to, as Manos mentioned, to join the session tomorrow, which will discuss further the expansion to wrist-worn accelerometry. Secondly, we observed that distribution of devices to participants in person is associated with higher rates of consent and higher rates of adherence. Obviously, this is not always going to be possible, particularly where studies cover a large geographic area, but perhaps something to note that when it is feasible, it may be an important benefit to the return of this data. And our last recommendation, I think recognised by many as a clear research need, is that almost all of the study waves included in this review are from high-income countries. And that actually expansion for international consortia, like ProPASS, to include studies from lower and middle-income countries is a clear, important strand of our work. So again, please stay for the next session of the conference, which will discuss further ProPASS efforts to expand in this way. Thanks for your attention. I've covered quite a lot in a short space of time. So there's a QR code to the article on the left-hand side of the screen there, should you be interested in learning a bit more about this piece of work. Thanks, Andy.
That's excellent. Thank you very much, Richard. A great overview there of a very large and, I recall, complicated piece of work. We haven't received any questions in the Q&A, so I will just kind of encourage the audience again. Do post your questions in there if you have anything that you would like to find out from our speakers. If I can just jump in, then Richard, Manos set the scene for us at the beginning, how he sees the wearables landscape as it is kind of emerging, both in the kind of research context and in the more kind of commercial lifestyle kind of sense. I wondered, and he predicts that things will change and we will kind of come more into line, I guess, with that commercial. But I wonder if you kind of share that view and how you think that might change the kind of data that we get, the quality of data that we get from devices.
Yeah, of course. I think Manos is absolutely right. I think the landscape has changed and is changing. I think one of the really notable things from the studies when looking at the studies within this field and the studies that were included in the review is kind of a fairly rapid shift in terms of the devices and the device placements that predominate at a given time. I think the historically the majority of the studies use devices worn at the waist, and that's gradually changing and diversifying to the thigh, the wrist, and also the use of multiple devices and kind of diverse different types of device as well. So I think device placements will certainly change and continue to evolve. And also I think we're interested, as we said from the outset, for this piece of work in maximizing the data that we can collect in terms of capturing the largest possible proportions of a given day, but then extending that measurement for longer periods. And I think that across the measurement waves included in this review, the overwhelming majority were a week or less as it become kind of standard practice. And I think the potential for new devices and certainly consumer wearables, with even simple developments in battery life and onboard processing, and those longer measurement periods, which can better capture habitual physical activity, will become more and more common and will certainly benefit what we can understand about human behaviour.
Excellent. Thank you, Richard. Great presentation.